People miss out on their fix.
People what?
Missing out on their physics fix.
Hey, Abby.
Frequency. The symbol I use for frequency is the same F that I use for friction.
Why?
You know, there's a certain number of letters. We have with capital and lowercase Greek and American letters, Roman.
What's that about? Maybe?
They're only 100 characters. So,
What? 100?
yeah. All right, so frequency, F, and it's how often something happens. How often the cycle happens. Now, when we're talking about units, we're talking about cycles per, in SI units, it'd be cycles per second, otherwise known as, well, actually, what are the typical units of frequency that you might hear?
Like microwaves and stuff?
No, looking for units.
For what?
Units of frequency.
Hertz?
Yes.
Wait, what? Hertz?
Yep. So the units of frequency. The hertz, which is just a cycle per second, or typically just written as, or sometimes written as, just the reciprocal of the second. All right, now, just to add to the flavor of all of this. Not every textbook uses an F. Not every source that you might find on the internet will use the F for frequency. Instead, they will use the nu.
The what?
The nu.
Is that like another mu?
Nu. Nu. It is a Greek letter that looks like this.
Oh, so it's a reverse italicized V.
And in some sense, it's a V with a strong headwind.
With a what?
Strong headwind.
Oh.
Except in some fonts, it doesn't look like that. In some fonts, it actually looks like that.
Can we do the first one for the sake of making it not look like speed and velocity?
Well, actually, I use F so that I don't have to worry about that. But I bring this up because if you were looking at some other source and it does this, it might be confusing. You might be going, wait a second, is that a V or is that a frequency? Is that a speed or a frequency? Because in the font where this is the nu, V looks like this, and in this font where that's the nu, V looks like that. So it gets incredibly confusing. In my first year here, I had one of the nanotech students, because nanotech was over in the other building at the time, came down and said, why are there two V's in this equation? I said, oh, one of them's not a V. So how can you tell which one is the V and which one is the nu if you run across this?
One is fancy.
No, that doesn't always work. So before I do that, so that's put on the back burner, a little teaser, sort of the cliffhanger, to make you come back in, a minute. Let's talk about wavelength. Actually, before wavelength, let's do period.
Okay.
The symbol for period is the capital T, because it is a time, it's a specific time. It is time to complete one cycle of repetitive motion. And what the heck, let's try to spell close to the correct spelling. Repetitive motion. So since it is a time, what are the SI units for a period?
Seconds.
Yes.
Is it ever going to be anything other than seconds?
I mean, it could be hours. So we generally do.
But not minutes or something?
It depends. Seconds is the standard international
Will it be said
unit.
if it's something otherwise? Will it be said if it's something otherwise?
Yeah, or, and understood. I mean, what's the period of the Earth's going around the sun?
365 days.
1 year.
That would be somewhere, but you're both right.
It's simpler than the time I said 365 and a quarter days.
4.24, whatever it is,
Yeah, that's what I said.
248.
That's what I said.
Now, I write seconds here. There's an understood cycles per seconds per cycle, or seconds per oscillation, or seconds per whatever the repetitive unit is. And if you look at just at units, we have cycles per second and seconds per cycle, or seconds and 1/seconds. Frequency and period are reciprocals of each other. So we have this relationship that frequency is 1/the period, or for fans of wanting to keep period as is, 1/the frequency. If I mention battle ropes, do you know what I'm talking about?
Battle what?
Battle ropes, it's an exercise thing. You have long ropes attached to a wall, and then you do this.
Oh, that CrossFit thing?
Sure. Okay. You're picturing it?
Yes.
Okay. So if I've got, how often?
What's that T sub S something? That's just
Here?
SI?
This is the symbol for units of period and then SI. So these are the SI units of period.
Metric system.
Yeah.
Okay.
There's two different metric standards. That's why I assume SI specifically, and not just generically metric. All right, so if I've got two long battle ropes here and I'm doing this, and assuming that I'm doing it beautifully, because with imaginary ropes, I could go on for quite a while. The time it takes for my hand to go up, down, and then back to where I started in the same direction, that would be the period. Take the reciprocal of that, I have the frequency of the waves that I'm creating. Now, in the time it takes for my arm to go up, down, and then back to where I started, going in the same direction, the wave will have traveled a certain distance. The distance that it travels is the wavelength. The distance a wave travels in one period. The symbol for wavelength is a lambda, lowercase lambda. And they came up with that using the classic, wavelength is a length. What Greek letter begins with the L sound? Oh, lambda does. We'll use lambda.
Really?
Yeah.
That's dumb. Useful, but dumb.
So, what are the SI units for wavelength?
Any form of distance in meters?
Yeah, the SI would be meters, but in any unit of distance would be an acceptable unit. We'll put SI there. If you're using the CGS metric system, centimeters would be the common unit.
CGS?
Yeah, the two metric systems are the NKS system and the CGS system. NKS stands for meters, kilograms, seconds. CGS stands for centimeters, grams, seconds. It's establishing
I
just,
think I was taught the CGS in engineering class.
but SI is the NKS system. All right, so if I'm looking at the speed of a wave, so I'm producing a wave that's shooting along, the speed of the wave, V for speed, It's going to be the distance over time. And I meant to ask you, what's the formula for speed? So we'll go ahead and do that. What's the formula for speed?
Distance over time.
Yes. So if I'm looking at a time period of one period, so I'm looking for time of one period, the distance it's traveled is the wavelength. So that's just the wavelength times 1 over the period.
What does
We-
nu represent again?
We'll get back to it.
Oh, okay.
Which is the wavelength times the frequency. So a formula that we will use more than once is the fact that the speed is equal to the frequency times the wavelength. Or wavelength times frequency, depending upon your mood. This is the formula that allows you to figure out what's a V and what's a nu. Because if you see wavelength, if you see that formula, then you know their nu looks like this. If you see this formula, then the nu looks like that. So that's why that formula is important, because it, well, one, it allows us to apply the stuff we did in chapter 2 to the stuff we're doing in chapter 16. But also in textbooks where they're using the nu for frequency, it allows you to figure out what's the nu and what's the V. Of course, it's really helpful if they just do frequency, comma, and then give us the symbol that they're going to use.
Okay, I'm confused on what's directly below nu.
What's directly below nu with this?
Yeah, that stuff.
That's a nu.
Then what's the other V?
That's a nu.
And what's the one at the beginning?
This is speed over here. This is a V.
Okay.
This is frequency. This is a long drawn out reason why I don't use the letter that is used in a lot of physics textbooks, and I use the letter F. Also, if you happen to run across that version of frequency, instead of they don't use the letter F, they use the nu. This is how to tell which one's the nu and which one's the V. You look for that formula.
Okay.
One other vocab word here for waves: amplitude. If I'm doing some generic form, I'll use capital A for amplitude, as I did yesterday. And it is, I can put distance in quotation marks because it's not necessarily a distance. If I'm doing the battle groups, the amplitude would be a physical distance. But if I'm not doing amplitude, if I'm not doing a battle, for instance, I'm doing sound, then the amplitude is not really a distance, it is the difference between the maximum pressure and the average pressure, or maximum volume and average volume, depending on what I'm actually looking at. So the distance from average to peak, or average to trough. Peak being the maximum amount, trough being the minimum amount. So I probably should have just said that average to peak, maximum, and average to minimum.
There was no crash, was there?
They're just honking because they're celebrating you're taking physics right now.
No, I think it's construction.
It is, it's what, just.
And they're constructing to celebrate you're taking physics right now.
Exactly.
If you were not taking physics right now, there'd be no construction going on.
In the world,
And that's right.
Yeah, that's right.
in the modern world or any other world.
All right, questions up to here before we go back to what we were doing yesterday, now that we have a little bit more basis for it. If you recall from yesterday, I guess the one other thing that we deal with is angular frequency. And what the heck, let's put it over here. Angular frequency. The symbol is the omega. How often wow, how would I really define that? How often I'm just gonna say rotation happens? That's not good. I'm just gonna leave it as a mystery. Because it's related to frequency. It's go back to the wheel thing. It's I have a wheel that is rotating.
How often the cycle happens in a circular direction?
Yeah, I mean it's
This is what you got.
how often does the associated rotation that goes with the cycle happen? Which is very vague and I don't think particularly helpful.
Very bullish.
The unit's radians per second. PSI. Revolutions per minute would be the angular frequency in terms of different units that you might see out in the non-academic world.
Yeah. Can you just?
Okay. Let's talk about, because yesterday when we did the example, I had a spring on a horizontal frictionless surface oscillating back and forth.
Can you explain in vague terms that you did what angular frequency is again?
Go back to the wheel. I have a wheel rotating about its center.
Yes.
I have a peg
Uh-huh.
that is sitting out here that is rotating around. And the
Uh-huh.
wheel is rotating at some angular speed of omega. I have a light source up above, casting a shadow onto the floor. So right now the shadow is there.
Uh-huh.
As this rotates around, that shadow is going to be moving back and forth. How often the shadow moves back and forth is the frequency.
The angular frequency.
No, the frequency.
Oh.
The rate at which this rotates is the angular frequency.
So the rate at which a given object rotates around.
That would be associated with a frequency. Because if I have a slinky here that's oscillating up and down, it has a frequency. We
Yes.
can time how long it takes for it to go up and down, we can take the reciprocal, and we have the frequency. But there's an angular frequency associated with it, a wheel that is sort of mythically rotating at a constant rate which matches basically where this is at that time. So as that goes up and down, my finger should be, my
Pretty
coordination isn't
accurate.
that great, but the finger should be at the same height as the bottom of the coil.
Okay.
So my finger was moving at an angular frequency of omega. The coil was moving up and down with a frequency of F.
So it's how often the cycle happens, how often a frequency happens in a cycle determining relative to the cycle?
Let's say
is
associated with the cycle.
how often a circular cycle.
So I have a coil sitting here, and I got a mass, frictionless ground, I have a mass sitting here, I pull it out and let go, it's gonna oscillate back and forth. If I did a map first time, so let's just do sort of a vertical map, so if I did position first time, it starts out here, it's gonna then move back and forth, and if it's backwards. It's then gonna cycle back and forth as time progresses. And this, which is sort of more support for the fact that we were using a cosine or a sine curve to model it. But what if it's hanging vertically?
Wait, what?
What if I take my coil and I attach a mass to it and I pull it down and it oscillates back and forth? Is a cosine curve or a sine curve still a legitimate model? Because if I'm doing it horizontally, the forces I have acting on it are the force from the spring acting horizontally, and then I have weight and normal force balancing each other out vertically. But if I do it this way, I now have weight hanging down on it.
What that?
I have weight pulling down, and I have the normal and the spring force acting upwards.
Wouldn't you just have to change the positioning of the sine and cosine?
Let's find out. So, force diagram, as usual, so I have weight acting down, and I have the elastic force acting up. Actually, I'm gonna
Is
start.
elastic force different from the spring constant? I assume so.
The spring constant is related to the geometry of, and the material of the spring. It is related to the force, but it's not the force.
Okay.
So I start out with a coil just sitting there fat, dumb, and happy. It hangs with some initial, we'll just call it x sub 0. I then attach a mass to it, and I put it into new equilibrium. So these are both equilibrium. I have some